Okay, today we're going to work on our next section, which is graphing linear inequalities with two variables. However, many of you struggled with just graphing a regular line. So we're going to start today's lesson by having you partner up for a couple minutes and write a step-by-step instruction guide for graphing an equation. So you're going to use this equation, y equals 3x plus 2. So go ahead and pair up with the person next to you, review your instructions and make sure they're the same, and then graph the equation. Okay, when we graph the equation of this line, we start with the y-intercepts. Remember, you want your equations in y equals mx plus b or slope-intercept form. This is your y-intercept. This is your slope. Always start at the y-intercept. So you go up 2 and make a dot. So start at y-intercept, and make a dot, or a point, however you want to say it. From there, you go up 3, 1, 2, 3, and over 1, and make a dot there. So follows from there. Follow the slope. And it's rise over run. Which would be 3 over 1. Now you just drew a line in between your two dots. Or you could go up another 3 and over 1, another 1. Okay, since we all struggled with this so much, I want you to practice doing another line. So pause the video and practice this line. Once again, you started the y-intercept, which is going to be a -9 because it's -9. Then you follow the slope. You go up 3, 1, 2, 3, and over 4. You do the same thing again if you want to be more accurate with your line. I drew my third dot up 3 over 3, not 4. So I had to fix that when I drew my line. But that's the equation of the line. 5.5, graphing two variable inequalities, day 1. Today's objective, you'll be able to graph an inequality with two variables. Discussion, how would you graph x greater than 3? So we're always going to shade this to the right if it's greater than. So if we start at 0, go over to 3. A couple people struggled with this. They would just draw a dot, a random dot. It's an open circle because it's greater than and not greater than or equal to. And you shade to the right. How do we know how to do this? We just know at this point. But really, we're testing points. We're looking for what numbers could we plug in for x that would make it true. Like if I plug the number 4 in, 4x is 4 greater than 3. Yes, that's why 4 is one of the included points that's shaded. If I plugged a 2 in and said, is 2 greater than 3? No, it's not. That's why 2 is not one of the included points in our graph. We're going to do a similar thing to determine which side of the line needs to be shaded today. Example 1. Y is less than or equal to 2x plus 3. So first you're going to graph the line. Now, it's going to be a solid line if it's less than or equal to or greater than or equal to. It will be a dotted line if it's just less than or greater than. This is a less than or equal to, so it's going to be a solid line. So we start by going to the y-intercept. Same exact way we plotted lines in the last chapter. To go up 3, make a dot. Then from there you go up 2 and over 1. You go up 2 and over 1 again, up 2 and over 1 again. Solid line. Now we pick a test point. So I always pick the easiest point, which is 0, 0. Now, when we plug 0, 0 in for x and y, if it creates a true statement, then you shade on the same side of the line that 0, 0 is on. If it's a false statement, then you shade on the other side. So we're going to plug 0 in for y. 0 is less than or equal to 2 times 0 plus 3. 2 times 0 is 0, so you get 0 is less than or equal to 3. Is 0 smaller than or equal to 3? Yes, it's smaller than 3, so we shade on the same side that the point 0, 0 is. If that was false, then we would shade above the line. You could also just look at it. I'm pretty good at looking at it and being able to tell which side you should shade. If it's less than or lower than the line, then that's the side that you shade on. Example 2. Graph y plus 4x is less than negative 2. If we look at this to start with, is it in slope-intercept form? That would be no. You have to get the y by itself. So you have to subtract the 4x over. You get y is less than negative 4x minus 2. So we go to the y-intercept, which is the minus 2, and make a dot. From there you go down 4 and over 1. Now we're going to use a dotted line because it's just a less than and not an equal to. Now let's choose the point 0, 0. If I choose 0, 0 and plug it in, 0 is less than negative 4 times 0 minus 2. Negative 4 times 0 is just 0. 0 minus 2 is minus 2. Is 0 less than negative 2? I would hope that you all just said no. So since it's not less than negative 2, then we shade on the opposite side of the line that the origin is. So instead of shading on that other side, we come over here. Our original point was here that we plugged in. It created a false statement, which means you shade over here. Just clarifying in case you need. Example 3. Y is greater than negative 2. Do we have an x in this question at all? No. So we go down to negative 2. We make a dot. Now, if y is greater than negative 2, it means that y could be any point above it. But since there's no x, it could be any one of these x's. And so we have a dotted line because it's just greater than, at -2, and you shade everything above it. Here are 6 you try questions. I want you to pause the video and try them, then we'll go over all of them. Okay, number 1, y is greater than -2x plus 4. You start out by going up 4. 1, 2, 3, 4, and make a dot. Then you go down 2 and write 1, because that's the slope. Down another 2 and write 1. It's just a greater than, so it's a dotted line. Then let's try the point 0, 0. 0 is greater than -2 times 0 plus 4. 0, 0 is right here. -2 times 0, 0 plus 4 is 4. So you get 0 is greater than 4. Is 0 greater than 4? The answer is no, so you shade on the opposite side of the origin, or the point that you chose, because it did not create a true state. Number 2, it's not in slope-intercept form, so you have to add the 4x over. It gives you y is less than or equal to 4x minus 3. Go down 3, make a dot, then it's 4x, which means your slope is 4. Go up 4 and over 1. And there you go, up another 4 and over 1. That should be enough to draw the line. Now, it's a less than or equal to, so it tells you it's a solid line. It's going to be a solid line going through those points. Then choose 0, 0. Plug it in. 0 is less than or equal to 4 times 0. By now you should realize that that's always going to be 0. Minus 3 gives you 0 is less than or equal to -3. Since that's not true, you shade on the opposite side of the line. And what the shading represents is every possible value that you could plug in to make this equation true. So if I randomly chose this point over here and plugged it in, that would make it true. If I chose this point down here at 1, -10, that would make it true. If you don't believe me, -10 minus 4 times 1 is less than or equal to -3. -10 minus 4 is -14, and that is smaller than -3. Number 3, got to get y by itself first. So you subtract the 3x over. There's nothing in front of the 3x, which means it would be technically an adding. So we subtract it. That gives you -y is greater than or equal to -3x minus 1. But y is not by itself yet. You still have this negative over here. So you have to divide by a -1 on both sides. Those cancel, you get y. Now because you multiplied or divided by a negative, you flip the inequality. It makes this 3x plus 1. So we divided -3 by -1 and -1 by -1. You go up 1, make a dot. From there you go up 3 and over 1. Up 3, over 1, up 3, over 1. This would be a solid line since it's got an equal sign. And if we choose the origin, you plug it in, that will give you 0 is less than or equal to 1. That is true, so we shade on the same side as the origin is. Okay, number 4. Y is greater than or equal to 2x. There is no y-intercept, so it's plus 0. Start there, go up 2, over 1, up 2 over 1. You have an equal sign underneath it, so it's a solid line. Now the origin here is on the line, so you can't choose the origin this time. So just choose another easy point, 0, 1. That will give you 1 is greater than or equal to 2 times 0 plus 0. So 1 is greater than or equal to 0. So we chose this point originally. It created a true statement, so we shade above the line. Number 5, got to get y by itself first. We subtract the 4x, gives you 2y. It's greater than -4x plus 8. Divide by 2. Get y is greater than -2x plus 4. Now graph, you go up 4, 1, 2, 3, 4. Make a dot, go down 2, and write 1. Down 2, write 1. It's only a greater than sign, which tells you it's a dotted line. Then we plug in the origin. Gives you 0 is greater than 4, which is not true. So you go above the line. Last one, we have x is less than or equal to 2. So you go over to x is 2. Then it has the equal sign, so it's going to be a solid line. It's going to be a vertical line. And then it's all the numbers that are less than 2. Should be, everything on this side of the line over here. Okay, that's today's lesson. Make sure you are doing these questions. The very first section of the next chapter is going to be the same thing. This is your last section of this chapter, which means you have a chapter test coming up. 2 more days of this, chapter review, then a chapter test. Be prepared. Start pulling all your stuff together for chapter 5.